Hello. Welcome to my stream. My name is Andrew. I'm streaming software engineering, and right now I'm solving a problem I have with my YouTube channel, and this is a series of how I rewrite Python script to Golang and make it, let's say, less complicated. So let me check how it looks. Yeah, it looks better. So the problem I have a YouTube channel which requires attention. In order to make some job to generate a video, I need to execute a few scripts. It's one script with different options, and it requires my presence because it's SSH. I SSH to some remote server I have. It generates texts, series of images. I need to check them, approve, maybe replace some images because I'm not happy with something like color. Sometimes there is a problem which I encountered, I think, yesterday. The problem of video generation, picture generation at least. Let's say Leonardo da Vinci created his masterpiece, and some sort of model, AI model, has a censorship on muscle bodies, for example. I don't understand why that exists, why those censorship in AI for good bodies. What the hell? What the fuck? So I encountered it yesterday. That means I'm no longer going to use that model for image generation because it has censorship. Let's move it to dump straight ahead. I'll use something else. So that thing, current implementation requires my attention, constant attention for, let's say, 20 minutes in a row, because it generates videos. Then I must approve. Then I must watch if something happens in the middle. That's what I'm not happy about. So the project I'm making in this video series, it's about pipelines which requires my minimum attention. So my attention would be required at the stage of text, like video content. There is some sort of narrative things which requires my attention, and it will require my attention in the end. When I have the result, I will need to say, yes, I approve it, let's upload it, or no, I'm not happy, let's do something. To be honest, I would also include approval for picture generation. For example, if I have 4 pictures, I'm not happy with picture number 3 because AI made extra fingers. That means let's replace this picture or regenerate it. I'll think about it later, because right now all I need is just implement that solution. And there is architecture. I wanted to avoid central point of failure, single point of failure. There is no database, that's important. There is no cache. There are binaries, workers. There is shared storage, which can be replicated on RAID or whatever, but it's important, it's resilient, it can survive. It doesn't need anything except brew install and then export credentials. It's one file. Multicast DNS, well, it's not a big deal because on every Mac it is available. And let me show you my hardware. Pictures, yeah, this one. This is my hardware. I have two laptops. First laptop, it's 10 years old, I think. It no longer accepts any updates from Apple because there is no updates for outdated hardware. And the laptop below, it's the one which makes operations, a few operations today. It runs the Python script. There is also PC below. It's the one I'm streaming and gaming from, but it is important. It has GPU. It means it can run some models, and that will be one of those workers I would like to make. So the architecture, it's about, I have workers, there are binaries on some hardware, there is storage, shared storage. It's just for storing results or maybe some states of pipelines. We'll speak about it today as well. There is multicast DNS. It's default for every Apple OS as well as Linux. It's not a big deal. I managed to start this binary in VirtualBox Ubuntu. It used to sign up and announce itself as a worker in this flow. It's fine. I don't have Grafana for now, and Telegram / Slack, whatever messenger I will use later. It's also not implemented yet. It will be done later. So let's go further in the end. Here it is. So at last stream, I have defined a test. Let me find the test. It was here. Yes. So I defined a test with two blocks. That means that block 1 can supply data. This block should supply data to another block. That's quite important test because it will resolve a few problems. First problem, I will create interface to start pipeline from scratch. And second, this test will be used to second interface of pipeline execution. It's proceed. Let's say something happened on stage 2 in the second block. And here, for some reason it was stopped. Maybe HTTP error or whatever. That means I can restart this pipeline. And since it has its state in a shared storage, that means if the service number 2 will be available, this pipeline proceed. For example, if some sort of AI model censorship I'm not happy about will be replaced, let's say I remove that model or use another model, I can simply restart, resume this pipeline. It's not complete restart, it will resume with current progress. I remember that I was not happy about a few things while writing this test, and let's check. Yeah, so I created a few schemas about worker exchange. Let's assume, by the way, I will also need to update this schema because I found another solution. So let's assume I have a client. It might be Raspberry Pi, it might be Cronta, whatever, which goes to worker and says, hello, you have pipeline, let's start processing it. So it makes first request telling, okay, worker, you have to start something. Worker says, okay, your processing is ID 1. You can come back wherever you want to check it. Maybe I should do a webhook later, but for now it just yields the result. And let's say worker 1 has done the video, but it has stopped because it has no GPU. It was video encode, for example. What does it mean? It should say worker 2, hello worker 2. I cannot proceed, you have to resume this pipeline with some data. And here there was a mistake. So this was a mistake. So worker 1, it processes something in the pipeline, let's say 90%. Then it simply stops because there was some absent hardware capabilities, GPU, or maybe it's like my old laptop, it has 2 cores, it cannot work with some CPU heavy loads. So I can, in config, I can disable something and it will go to worker 2 with quite simple HTTP request, which is, hello worker, you have pipeline with this ID. There is processing number 123, resume it. That's the interface I would like to have. And that's all. Worker 1 can check processing ID. Let's say I make HTTP request from client, makes request to worker 1, like get pipelines, then pipeline ID, which can be some UUID, whatever, but then it can make processing ID 1. That means that worker 1 fetches state file from, it can fetch file from shared storage. That means whatever worker gets this request, it will always go to shared storage. There's no need to keep this state in binary itself, because I was thinking about having some Go routine in worker 1 in order to keep the state there, but then I got it, here it is, check storage for processing ID 2. Now I don't have this storage. Check storage for processing ID 1. Where is that loop? Oh, it's here, it's 1. Maybe this picture hasn't been updated. Let's check preview. Yes, now it's 1. And this picture no longer needs this. So when I have a request from pipeline client, processing ID 1, where is it? Here. So worker 1 says start processing. Yes, worker 1 to worker 2. Proceed. It's not proceed, it's resume. Pipeline with processing ID 1 at block. That would be correct. Worker 2 yields some response to worker 1 with the same processing ID. It is important. Maybe I should say just HTTP 200. It is done. No longer tracking needed. As well as check storage worker 2. So in this case, pipeline client can ask any worker check state. Yeah. So a pipeline may ask a worker to check the processing. Is it finished or not? And that means worker one can ask for shared storage. Where is it? No. There was loop name check storage for processing ID. Ah, yes, the same. Check storage for processing ID. Yes, that's correct. And then it should simply say pipeline client result state of processing. Yes. Then it is important that the same flow might happen to any worker. It might happen to worker 2 as well. And that's what happens in a schema when I have no cache, no state. My state is in shared storage itself. So here, check if processing finished. I go to the file. I might also fetch this file and simply yield it as a response. And I also can ask any worker to check that file. That's all. There was another quite big problem. When I was implementing the test, this one, I was thinking about shared registry. Let's say in here, the schema is quite small. How do, whoa, easy. Can I open it in a new, move to new window? Yeah. And it's, no, it's not empty. I hope you can see it. Now you cannot. Nice. I'll keep it here. Yeah. So I have worker 1. It has pipeline registry. That entity exists today, right now. That pipeline registry, it simply reads all files with configs. And since I have a file with pipeline itself in here, it's a JSON of what this pipeline is, what blocks they are. So that is my registry. It exists, it validates requests, validates pipelines for existence. There is also a block registry. It's a list of blocks. There are detectors. I made, I think, last week, I made a few watchers. They are keeping themselves in some threads, and once upon some period, they are checking if hardware has been updated. If there is some GPU, maybe there is no network access, like I think it was here. Blocks, block HTTP. Yes, there is detector HTTP. And there is quite simple function named getURL. And the block itself, it had a code for, no, it was in block registry. Yes, here. It had detector. So detector was running in some Goroutine. It should be the classes. Oh, it must be here. Okay, start. Server worker, block detector. Yeah, here it is. It's simple. It has a simple goroutine, which ticker comes from config, and it makes detection function and sets it available or not. So the registry of blocks and pipelines, it's a singleton. It exists through the lifetime of binary or whatever you can call it. Let me check on. Yes, each block has detector. HTTP checks itself for each minute. OpenAI checks itself each minute as well, but we might make it like 30 seconds. But let's keep it as 1 minute as well. So the problem, I'll come back. Let's say this registry contains two blocks, block 1 and block 2. But pipeline requires block 3 and block 4 as well. That means I have a registry which is entry point for each operation, pipeline registry itself. So when HTTP request comes, it strikes straight to pipeline registry. It's also implemented in worker in HTTP handlers as well. Here it is. New pipeline, when it started, it visits registry and tells it, okay, I have request, and let's start this pipeline. The pipeline checks if pipeline exists. If it does exist, it yields some result, which start processing. It checks blocks, whatever. But what's most important, it does not check if every block is available. That's a problem. Because let me check block registry. It was somewhere here. Oh, here. So the code I wrote was quite straightforward. There is a cycle. I have list of blocks in this pipeline. All I need to do is check if it's available, then I can proceed processing it. But if block is not available, that means there are two ways: yield an error, or why it's always scrolling to the wrong place. Either yield an error or make request to block registry. So let's say block 2. Okay, entry point, pipeline, start processing. Pipeline goes to block registry. It checks, okay, I have this block, I can proceed. Then in this cycle, here, in this cycle, it checks if the block is available. That means after block 2, block 3 is not available. It will yield an error, but that's not true. Block 3 exists in another worker. Since multicast DNS advertises some additional tags, my workers do have blocks advertised. So if I run make start, there go make start. Yes, there is an error, obviously. They advertise each other. They say, okay, I have this list of blocks, but there is a problem. If it's a GPU block, it might be utilizing GPU for 100%. That means no new requests are allowed. That means I need to implement shared block registry. Pipeline registry, it's common for everything because it's in one file itself. Its only job is to validate that request is correct. This pipeline is correct. Block registry, it's a bit different thing. It's constantly updated entity. And that means in order to do things like this, when I check if block is available, I need to update block registry itself in order to proceed working with current stuff. So I have a problem with on this stage of development. To be honest, it's not that big deal. Is to implement shared block registry. What it means that every worker on its startup must not just advertise itself into multicast DNS, it must send some sort of request to each other worker about its blocks. Maybe there is better way. Since I have this in here, discovered workers, I have this code. There is go routine. When binary starts, every 5 seconds, it's making requests to multicast DNS to discover new workers. So this is how it works. This is the body of this function. Set discovered workers. I do remember that these discovered workers also contain blocks, but for now it's just a list of strings. How to detect if this block is available or not? It's to make request. That's the idea. So, coding on stream with font. The problem is to implement share block registry. Because this, where is that code? Yeah, this code, no, Python, yeah. This error block is available. The function implementation of this interface, it should be that simple, but behind is available. There must be something else. Yeah, for now, there is one Boolean property named is available, but there should be a request. Yes, request. Share block registry. Share block registry is constantly updated mapping of blocks and workers. What it means, let's say on this schema, worker 1 has no GPU. That means when worker 2 goes online, worker 1 it is aware of worker2 because of that function. But to check availability, it's pipeline itself which must request worker2. So there is another connection. Block availability is pipeline request, pipeline block request how to say it correctly, responsibility. Yes. So in here, when I check if this block is available, I need not just yield if it's available true or false, but this available function, available property, it must be related to locally available. Yes. Local available true. Maybe I should call it a bit different. Let's call it available. Yes, as it is. But since this block has connection to registry, let me check if there is a method. Schema loader output. Yes, it has connection to pipeline, which means it should have connection to registry. Let me check. B get pipeline. No, it's not the block which has this. It's data which comes. Data has connection to everywhere. I would like to use this easy interface. Maybe. Yes, that's correct. This block, it's local availability. Block local. Block is available, yes. So if block is not available and this is pipeline data which has connection to pipeline as well as registry. So let's make it block remote available false by default and not block remote available. Then we have an error. Block with lock is not available. That might be misleading. If it's not available locally, then I need to check if it's available on another worker. And worker registry. It's not correct. I would like to introduce an error which will not be some sort of magic. Let's make it this one. It's not transfer. Block with lock is not available on remote. Locally. Yes, that would be correct. So in this case, things are not available locally and remote. That's good. But if it is available locally, it is available remotely, I need to make a call to worker registry. Unfortunately, I do not have this registry. And this is what I will have to implement, because after that, if I don't have this block available locally, I can do break. I have no need to process anything. In here, else, it's just dirty draft code. It will look differently. Maybe I should do this one. Yeah, that would be correct. So this function start processing. It processes something through loop, and if shit happened, it should simply, if block is available remotely, then return response, maybe. That's the reason why I need remote storage, worker registry. Worker registry, registries get worker registry, and in here I should say worker registry dot resume processing. That's a place where a few things will start being odd. In here, processing ID. In here, I should say by default, if everything was fine, processing ID is, and in here, resume processing, processing ID. And what's important, I need to say which block is behind. Yes, block data dot slack, I think. Get slack. Yep. Also, there is one more thing missing, block data get pipeline. I think this interface is better. I have pipeline, I have processing ID, and I have a block. That is looking just like this. Pipeline Slack, processing ID, and block. So this interface, this one, it's what has initiated this particular processing. Like in the test, where was the test? Here it is. It says, okay, let's register this and start processing with some pipeline Slack, block Slack, and maybe some input. In this case, when I say process proceed, resume this processing, I should also say which worker registry, get worker registry. Then I should say, okay, proceed processing, resume processing. I don't need to say anything about worker because this particular interface, it should be quite straightforward. I have this block, I have this get slug. Yeah, that is correct. Processing ID, and then start this block. Should I pass any input? I don't think so. So that's what should be there. Maybe even better. This one. in this case, resume processing will yield me either error or not. If there is no error, yeah, that's what it is. If r equals nil, then return processing ID nil, because this processing is already somewhere else. It has the same ID. I don't need to do anything. I need to return from this cycle. Everyone is happy. But if something happened else, if something happened, first of all, I need to return error. Yes, that's good. Maybe even better. If there is something odd, then yield an error. Other way, yes, that's better. Now I need to implement two things. First thing, it's worker registry. Second, block discovery. Fortunately, I have two things. There was an error in here, block data, I don't need it. So every time resume processing hits something, this particular function will be executed. It's like recursion. I'm happy with this. But you know what I'm not happy about? It's start processing. I need another function named resume processing. It's like here. It's not set blocks, but resume processing. Processing. What was here as an input? Data storage. Nice. Here. Return. Okay, this function should get the same input, but pipeline input. There is processing ID. Nice, nice. So it should not return just UUID, but data processing ID. Nil. So in here it says processing ID is a string, which is correct. I made it pointer because it might be empty. By default, it's empty, by the way. Let's say I made empty. I don't remember how it was done. Meet empty, maybe like this. But okay, let's do the following. Because it's a string, in here it must be converted, first of all. UID must. I don't need a panic. I need must. Yeah. And if in here I should return processing ID. No, this one. If earlier, yes. What's wrong in here? Ah, they mean like this. It's not a pointer. Come on, what's wrong? There should be a method named parse. Okay, data pipeline processing ID. It yields UID and error. Nice. Beautiful. Now it works. So that's an entry point for this. That also means I need to check HTTP interface in here. Pipeline start handler. I have it, but there is no pipeline proceed handler. That's awesome. Let's make it. Proceed handler. It accepts a registry. Yes. It accepts the same input, but in here it's not start, it proceed. It proceed. Registry proceed pipeline. In here I have start pipeline, which is awesome, but let's say there is a copy named proceed. There is also a problem because start and proceed, it has the same interface for input. The only difference proceed processing in here. It should be the same. Okay, now it's no longer. So it has the same code with only one difference. It is, where is it? Here. So start processing, it's simple. It wasn't here. Fortunately, I have updated it. So the problem, start processing should utilize every block in its cycle, but proceed, it should start with some block which slug has worked. I see here that I have already created the place. I'm checking input. If there is block, here is the place. So I don't need start processing. I might call it, I might leave it as start processing, by the way. Let's do this and come back to registry proceed pipeline. That's correct. Pipeline proceed processing. Maybe I should use it as a start processing and resume processing. Why did I call it proceed? This one. Maybe it's even better process. Let's rename it. Oh, maybe we should not do that because let me check start pipeline. Resume handler. Resume pipeline. In here, start pipeline, resume pipeline. Yes, that's correct. In here, I can say resume handler, resume pipeline. Yes. It's in registry. In registry, I call start processing. And there was a problem. Where is it? It's handler. Oh, yes, I think I remember. By default, processing ID is brand new, but then I need to ensure a few things. If data pipeline processing ID is not nil, then I should parse it. Yes, that's correct. And if is not nil, if error is not nil, yes, let's keep it as this one. Resume processing. It will be pipelines handler. It will hit here. By the way, there was a server go. Not here, it was in CMD. Yes, command. And here it is. So I have start for pipelines, but there should be resume. There is also one problem. Since there is no difference between start and resume, why would I need a second handler except logging some stuff? The pipeline is the same, everything is the same. Maybe I don't need this at all, because I can always hit the same. It's post-RIA cost. So this is a problem I was thinking for a few days. Would I even need that? Because the body of request contains processing ID. I don't need to include it in here, like this. I don't need to include it because it's inside of post request itself. So let's keep it as simple as possible. Pipeline start handler, pipeline resume handler. I would like, it's tempting to use the same, but why would I need to resume? Let's make it separate handler, because right now I see I don't want to create a good object, so-called. Yes. It will be resume handler. Resume handler utilizes resume pipeline with the same code as this. Resume pipeline utilizes start processing. Okay, but to be honest, it's not start processing, it's process. Here, process. So in this particular case, start processing, let's rename it to process. Renaming not possible because has errors. What kind of errors? P what? There is something not implemented. LF interfaces. Cannot use. Do not implement missing method process. Beautiful. And now, also let's comment this. Right now it has no errors, which means I can try process. Renaming method failed. Okay. It seems I will have to do it manually. Start processing. It is used only here, which is fine. Process. In here, it is also process. And then in tests. Let's rename it. That should be it. Oh, there is an error. Beautiful. It's worker registry. So, interface has been resolved. I have one method, which means it can proceed, resume. It can start from scratch, which is also fine, because input interface is the same everywhere. It has slug and the processing ID. If processing ID is missing, it means let's start new. If it is here, then let's execute existing pipeline, existing state. And that solves one of these problems. Shared block registry. Yes. So there is no longer difference between resume and start. That means shared registry, shared worker registry has only one endpoint, which I can call quite straightforward. And that is the place which should be implemented before this test. Shared worker registry, I think, should be implemented before. But what if those blocks are on one machine? Should I do this? Each block can be processed once on one machine. That will solve a few problems. So let's assume pipeline registry will calculate only once. So I have request pipeline contains one block, which means, okay, let's schedule this block for one worker, this block for another worker. And if I have situation like this, where is this config? When I need to, here, when I need to wait for, it's 1, 2, 3, no, it's 2 blocks. I remember that I had a block containing 4 different, yes, this one. So let's assume I have a block which should wait for something, wait for 4 different inputs, 4 different blocks. That means pipeline may schedule blocks across whole infrastructure. Let's say there are how much blocks? This pipeline contains 18 actions, 18 blocks. I have 3, let's say 2 devices. So it will schedule 10 blocks for device 1 and maybe 8 blocks for device 2. And each block will have to wait for its input. It looks like wait groups in Golang. Let's assume I have a sync with group. I don't remember how it was. VG, I think this one. It will be pipeline lock. Then I have a cycle for some blocks. Pipeline blocks. And then I simply say pipeline log. Let's add one. Yes. Then I say block. Even better, worker registry. Get worker registry. It should be here. Scheduler, schedule, block. And then I say pipeline log wait. If I do this, it looks better in some sort of this case. So let's say I have two workers and 6 blocks. How will it look? Worker 1 will have blocks 1, 4, and 5. Worker 2 will have blocks 2, 3, and 6. Because of block 1 needs no input, it will be executed, and then each other block should have some sort of wait inside. This is what I don't want to do, because this code will make centralized log, but it looks good. I would like to do this. It's simple. Okay, let's schedule this block to be executed there, and each block will contain some sort of code. Block processing will look like start, wait, like wait for dependencies to finish, process, finish. That is what I don't want to do. I don't want to notify other workers. It is important because this block, it's not aware of anything. It just executed there. Block number 2 will have to wait input of block number 1. How it is done? Maybe there should be some sort of sleep inside, like sleep 10 seconds. Block 4, that's interesting. Block 4 is a pull HTTP request to fetch approve. That's what I would like to note. I have one of my blocks. It's to fetch something from somewhere, which means this pipeline at stage 4 will be blocked because I'm sleeping. I cannot approve anything. I'm out of office, whatever. It must wait. That means blocks 5 and 6 will also have to wait indefinitely. There should be some sort of, if shit happened at block 4, I don't want to make notification for other workers. Also, this architecture is vulnerable to a situation when my laptop has problems with battery. That means worker 2 will simply say, hello, I'm offline. And that means blocks 2, 3, 6 will be somewhere else. So this was tempting, but not good. If one worker goes offline, that means no need to do anything. But in this case, yes, in case of don't save. But in this case, it's quite straightforward. One worker delegates registry to proceed. If there is an error, let's say this error, what should I do? To be honest, nothing, because resume processing, it's the function which will pick worker, ask him, are you able to process this data? Worker says yes or no. If it says no, then it takes another worker from the pool. That's solution, yeah. So each worker which will receive data will take care of it. If it cannot proceed at some stage, like say here, if it cannot proceed here because it doesn't have this block, it will yield an error, which means resume process, and shared worker registry should say, hello, there is another worker with this GPU or whatever, let's go there. That's what I would like to do. Implement shared block registry, shared worker registry. Shared, constantly updated. Maybe worker registry is constantly updated. Using metadata, using data from /pipelines and /blocks. It's HTTP endpoints in every worker. Here it says, okay, I have these blocks right now, they are available, but maybe I don't need to do this, it's not constantly updated. Shared worker registry should make resume processing. Did I call it resume processing here? Yes. Should execute resume processing with respect of worker query to pipelines and blocks. So this function, which called /blocks to the worker from the pool. Each worker in DNS, it will contain list of blocks, but there is nothing about if this block is available. That means at moment of processing, it will make request, hey, you said you have GPU, is it available? There is yes or no. Fine. And that's what I would like to do. Let's say tomorrow is Tuesday, September 10, yeah. September 10. Implement worker registry and resume processing method. So that's what I would like to do. There will be unit tests, obviously. It's quite straightforward to simulate something like here. Unit tests, hello. Block HTTP test, yeah. So I have similar situation here. I might mock worker panic. What if worker has panic when resume processing was triggered because GPU is available? That's what I can do. And that's my commitment to have it in Wednesday. So that's the state of development of this. I'm happy that I've spent like 2 days with thinking about this. It was not about let's implement code, let's write this code, because if I write the code which supports 2 blocks on one machine, that means I'm ignoring huge chunk of job. With this, I can see a bit further rather than 2 blocks. I can check that the code to run this block, it will be simple for with one simple condition. It won't be some crazy stuff. So that's what I would like to do. Also, there will be another problem. I already see it. It's a problem about input config particularly. And no things. It was in config. Where is it? Yeah, here. This one. It is related to shared registry as well as shared storage. So each output is saved to shared storage. That means this particular thing, it's about let's go to that storage, check the state of this pipeline, and take a file from catalog. It will work with shared storage, but I would like also introduce some sort of request sharing. Okay, let's do it later. So I'm happy to share these kind of updates, and see you in 2 days. Thanks for joining. Bye bye.